For this lesson, we are going to talk about systems of linear equations, and a system is when we have a set of two or more equations with the same variables. So the definition does say two or more, but in pre-algebra and even algebra 1, we will only look at two equations at a time. So don't get too concerned about having a lot to do. The solution of a system. So when we're asked to solve the system, we are being asked to find the ordered pair that is a solution to all equations in the system. So in other words, if we graphed our two lines, where would the two lines cross? So where would that ordered pair, what is that point? We have three options. We have one solution, and that is where the two lines cross at one point. We have no solutions, and that's where our lines will never cross. So if we have lines that are parallel, they're never going to cross, so there's no solution. And then we also have infinitely many solutions, so that is where the two lines are the exact same and they cross at every point. So three options, just like we had when we were solving equations. Then we have four vocab words here. If you're asked to classify a system, these are the four words that they're asking you about. So a consistent system is one that has at least one solution, one answer. So it could have one solution or it could have infinitely many. And then an independent system has exactly one solution. A dependent solution has infinite number of solutions. And an inconsistent system has no solution. So those four words are definitely important to us, and you need to have those written down so that you can answer the problems that ask you to classify the systems. So here, let me see if I can fit this all on one here for you. I have pictures drawn out of the exactly one solution and the classification. If it has exactly one solution, then it's going to be consistent and independent. And underneath of that is a picture of what that would look like. In the middle, we have no solution, and that would be called an inconsistent system. And then underneath is a picture of parallel lines where they never cross. And then last, we have infinitely many solutions. Those are classified as consistent and dependent. And you only see one line there because infinitely many solutions means that the two lines are the exact same. So there's no way to show that there's two lines there. All right, so we are going to compare the slopes and y-intercepts for the equation in this system. And then we're going to graph the equations. So how many solutions does this system have? So compare the slopes and the y-intercepts first. So remember, the slope is m, and the slope is in front of x. And if there's not a number in front of x, it's a 1. So we have m equals 1 and m equals 2 for the two equations. And b is the y-intercept. So the first equation, b is -5. And for the second equation, b is -6. So different slopes, different y-intercepts. So now we're going to graph these on our line over here. The first equation is y equals 1x minus 5. So that -5 is where we're going to put our first dot on the y-axis. So y-intercept is -5. And our slope is 1. So that means from that dot, I'm going to go up 1 and over 1. And I'm going to put a few extra dots just so it's easier for me to draw my line here and try to connect them. So there's that equation. And then next we have 2x minus 6. So -6 is our y-intercept. So we're going to put a dot there. And our slope is 2. So from that dot, I'm going to go up 2 and over 1. So 1, 2, up 2, over 1. I'm going to do that a couple of more times. And then we're going to draw a line here. So there's our second line. Oh, I'm still drawing lines. Okay, so how many solutions does the system have? It has one solution because the lines cross at one point. And that answer, we would go over 1 and then we'd have to go down 4. So 1, -4 is our answer here. All right. This top equation is not solved for y. It says y plus 1 equals 1/3 x. So I'm going to have to solve this equation for y. So over there on the side with the y, we have a plus 1, and I don't want that plus 1 there. I want to subtract 1 from both sides. I just want y. So the 1's cancel. And then I have 1/3 x minus 1. They are not like terms, so I cannot combine them. So I just write 1/3 x minus 1. And then we can graph from there because that's an mx plus b form. So -1 is our y-intercept, so we put a dot at -1. And 1/3 is our slope, so we go up 1 and over 3. And again, I'm going to do that a couple of times. And I'm going to go backwards, so I'm going to go down 1 and back 3 so that I can continue my line. Try to line it up. There we go. So there's that one. And then I have 1/3 x. Y equals 1/3 x. It doesn't have plus or minus at the end. So if there's no other number, it's a 0. So our y-intercept here is 0. And our slope is 1/3. So we're going to go up 1 and over 3. Up 1 and over 3. Up 1 and over 3. Then I'm going to go backwards. Down 1 and back 3. So these are parallel lines, and they have no solution. There is nowhere that those two lines cross. So let's take a look at the slopes and the y-intercepts. So the m value in both equations is 1/3. The b value in the top equation was -1, and the b value in the bottom equation was 0. So whenever we have the same slope, you can tell that they're going to be parallel because they're never going to cross. And they will never have a solution. So when you're looking at your two equations, if you notice that, then you know automatically it's no solution. All right, last one here. The top equation is solved for y, so we can go ahead and graph that. -1 is our y-intercept, that number by itself there, so we're going to put a dot at -1. And then 3 is our slope, so we're going to go up 3 and over 1. And then we're going to draw our line. Okay. And then our second equation is not solved for y, so we have to add 3x to both sides because we want that y by itself. So the 3x's cancel, and then I have -1 plus 3x. They are not like terms. They need to both have x's to add them together, and these don't, so we can just write -1 plus 3x. So -1 is my slope, or sorry, my y-intercept, and 3 is my slope, so up 3 over 1. And as you can tell, this is the exact same line. So this one has infinitely many solutions. And let's take a look at our slopes. The m value of the top equation was 3. The m value of the bottom equation was 3. The b, the y-intercept value of the top, was -1. And the b of the bottom equation was also -1. So everything was the same. So if everything's the same, it's infinitely many. If just the slope is the same, it's no solution. And then if everything's different, it's going to be one solution.